All right, go whenever.
Hi, we are Team 6, and this is our project proposal presentation. I'm Leo Ferrara.
I'm Darren Korn.
I'm Eduardo Barajas.
And I'm Merrick Fortaleza.
This is our project.
So we have a problem. Doctors need a vehicle to reach their patients in a location to give them medical aid and support while also transporting them.
So these are our criteria and requirements. On the right-hand side, we listed seven criteria requirements for this project. And with those requirements, we listed five criteria on the left-hand side in descending order from how important they are to us. And with these criteria and restraints, we came up with the proposal design on the upcoming slides.
So my the design that we thought of, well, the design before that, we decided very bulky design like a lizard type shape or a design like a Jeep. But this design in particular is a wonderful design based on the open space, the very simplistic outer edge, so it's very identifiable and noticeable. There's also going to be an X-ray machine inside of the vehicle, also having space in the front and also the back, with move a movement of the solar panel, so you can move to any part of where the sun is.
So yeah, so with that wonderful vehicle, we have how to power it. The question of how to power it. And like the requirement says, it's through solar panels. And so we had to decide how we would wire these solar panels and how we would achieve the required torque to move this massive vehicle with just solar power. And so we chose to wire the panels in series, or sorry, parallel with each other as to increase current while not changing the voltage. And then when it comes to our torque, we ran multiple simulations and used our lab knowledge, our lab data, and formulas to find the necessary torque that we needed in relevance to our or in relation to our mass. That so we can now adjust the mass to whatever we need and find the required torque output. And to achieve our required torque from our small motors, we use a gear ratio that is greater than one to increase the torque of our vehicle, or sorry, of our motors with loss of speed uh, in relation to that.
This is our automation. Our circuit on the left, circuit one, is the main automation part for the vehicle. The biggest part about it is there's an auto braking system using the ultrasonic sensor. It'll shoot a sound wave in front of the vehicle and it bounces back when it hits objects, so it can detect the distance between the car and the object in front. And if it gets too close, it'll start slowing down and stop. And that's the main part. And this will help the vehicle be more safe, like just in case like in these rough terrain that we're in, like while we're maneuvering it, something can like just change randomly and the driver can't react to it. The second part is there's a infrared controller to help control the vehicle. It just uses the buttons on the remote, and then that will make it go forward and backward. And then while going in reverse, there's a buzzer and a light that turn on to alert like nearby people that it's reversing so it doesn't hit anyone that it can't see because it's kind of hard to see all around the vehicle as the driver.
Okay, so for circuit two on the right-hand side, that design is meant for the siren of the vehicle. So we implemented an RBG LED light so it could change from a red light to blue light. And we added a piezo speaker to make that siren effect. And we added, why is this important for our vehicle? It is because it's works as just a regular ambulance siren just to get from one destination to another, alerting cars.
All right. And for this proposed design, we have a estimate of our budget based on the criteria and guesses or best guesses that we have of what we will need to build this. And so far, we are about 19 million, or if you want to do $19, under budget, which is awesome because it means we have a lot of room to improve and innovate on and to use maybe more expensive materials and once again, this is a rough estimate and something that will definitely change over time. But currently we are under budget by a very good margin. So that is our current budget. And in conclusion, this is a very for our stakeholders and what they require. This vehicle does all of the things and more. It has a lot of good automation that the stakeholders weren't even necessarily asking for, but that will help improve the quality of life of like the doctors, and without hurting the bottom line of the Doctors Without Borders and going over budget. So, like I said, the pros of this vehicle is under budget. It does, in fact, meet all the criteria and restraints that we have outlined. It has automation, which allows us to be innovative and different from the other designs that are out there. And it's overall a very functioning design. Thank you very much.